Okay, number one, Claudius could walk 25 miles to Pompeii in 2 hours more than it took Tiberius to drive 45 miles to the sea. Find the rate and time of each if the rate of Tiberius was 3 times that of Claudius. So this is one where they tell us both distances. So Claudius is walking 25 miles and Tiberius is driving 45 miles. So let's just go with Claudius and Tiberius as our categories. And the first thing I can see very clearly is how far both of them went, so we know exactly how far they both went. We put them in the right location for each person. Claudius 25 miles, Tiberius 45 miles. And of course, if I identify here that miles is my unit of distance, we can see hours is my unit of time, and miles per hour is my unit of rate. Just getting proper units is sometimes helpful in these problems. What I'm looking for is, I'm allowed to use a variable for rate, a variable for time, but not more than one of each. And what I'm looking for is relationships in the rates and time. So Claudius is taking 2 hours more than Tiberius. Right. Claudius is 2 more than Tiberius. So if Tiberius, let's say, is t, Claudius is 2 more than that. So t plus 2. The other option would be to make Claudius t, and then Tiberius be t minus 2, because if Claudius is 2 more, that means Tiberius is 2 less. Adding is always safer than subtracting, so I'd go with the addition one. So t for Tiberius, Claudius 2 more than Tiberius. The other thing says the rate of Tiberius, wrong, the rate. The rate of Tiberius was 3 times that of Claudius. So they're telling me that Tiberius is going 3 times faster than Claudius. So if Claudius is going at some speed r, Tiberius is going 3 times that fast, so 3 times r. Make sure it's multiplication happening there. Once I get something in the rate, something in the time, and something in the distance box on each of these, it's rate times time equals distance. That's how you create the equation every time. So Claudius, the rate of Claudius times the time of Claudius is equal to the distance of Claudius. The rate of Tiberius times the time of Tiberius is equal to the distance of Tiberius. So that'd be priority one, is to set up this little system of equations here. Both equations can be simplified a little bit, so the first thing I would do to the top equation here is I would do the r through the parentheses. So I'm going to get RT plus 2r is equal to 25. The bottom equation, I've got 3RT equals 45. I can divide by 3, that gets me RT is equal to 15. And if RT is equal to 15, and RT lives in the other equation, I can replace this RT with a 15, because they're equal to each other. And now the top equation, you can see the only variable left is r. So if I go ahead and finish solving this, I move the 15 over to the other side, minus 15. That gets me 2r is equal to 10, so therefore r equals 5. If I go back to my chart over here, I can find r to see what r represents. R is the rate of Claudius. So if I put, let's say Claudius and Tiberius are my 2 people in this problem, I can put rate equals 5 for Claudius, time equals something, rate equals something for Tiberius, time equals something. Okay, once I know Claudius's rate is 5, I can go back here also and start figuring stuff out. If this is 5, 5 times 5 makes 25, so t plus 2 is 5, which makes t is equal to 3. So if t plus 2 equals 5, therefore t is equal to 3. Well, 3 is Tiberius's time. 5 is Claudius's time. We also know Tiberius went 45 miles. 5 times 3 is 15 miles per hour, be Tiberius's rate. I could have also gone 3 times 15 makes 45, take your pick. 15 miles per hour for 3 hours, 5 miles per hour for 5 hours. We have both their rates, both their times, and that's the right answer. Now, the way you can determine that the right answer, it's real simple to do this. Make sure everything in the problem happens as it should. 5 times 5 is 25 miles for Claudius. 15 times 3 is 45 miles for Tiberius. 5 hours is 2 hours more than 3 hours. Claudius's time was 2 more than Tiberius's time. Right. 15 is 3 times as big as 5. Tiberius's rate was 3 times that of Claudius. Verify that all the criteria in the problem are met with those answers. That verifies that you have the correct solution. Number 2, the elixir was much too powerful. It was 400 milliliters of it tested at 76% alcohol. How much alcohol had to be evaporated to reduce the alcohol concentration to 36%? So every percent here represents alcohol. We're evaporating alcohol, which means we're taking away pure alcohol. So if we set up our initial structure, we're taking away pure alcohol in order to reduce the percentage of alcohol in this elixir. So what we start off with is 400 milliliters, that is 76% alcohol. We're extracting some unknown amount of alcohol from it, which is 100% pure alcohol. And our end result should be 36% alcohol, but we're going to have less elixir. 400 is what we started off with. We're evaporating X milliliters, so we're going to end up with 400 minus X milliliters of elixir in the end. So that's the setup. And again, pure is either 0 or 100. So look at the percents. Percent alcohol, evaporating pure alcohol, so 100. If it was, let's say, salt, and we're evaporating water, that'd be 0% water. So again, do the percentages deal with the same material or not? That tells you whether it's 100 or 0 there. All right, 76 times 400. Can't use the pen to mark these. Try again. 76 times 400. There we go. 30,400 minus 100x equals 36 times 400, 14,400. Minus 36x. So I'm going to move the 14,400 to the left. I'll move the 100x over to the right. In both cases I've got subtraction happening because opposite signs. So this leaves me with 16,000 and that leaves me with 64x. So to get the answer I simply divide by 64. 16,000 divided by 64 comes out to 250. And what it's asking for is how much alcohol has to be evaporated. X is what's being evaporated, that alcohol, right? So 250 milliliters is exactly what we're looking for. That's the final answer. It's not asking for how much elixir we end up with. It simply wants to know how much alcohol to evaporate. So if I'm watching this jar, let's say it's in some sort of graduated cylinder, and I'm boiling it so it's evaporating, the alcohol, the liquid in there is going away. When the amount drops down to 150 milliliters, that means we've taken 250 milliliters out. I take it off the heat, and the evaporation stops, and I'm left with a 36% alcohol elixir. Number 3, system of 3 equations with 3 variables. The first priority is to reduce this whole system into a system of 2 equations with 2 variables. And this type of statement is very helpful in making that occur. X equals 3y, so I substitute here and here to get rid of the x in the other 2 equations. So if I do those substitutions, the top equation, this one, changing x into 3y becomes 3y plus z is equal to 113, which becomes, if I add like terms, 4y plus z is equal to 113. This equation here, if I change x into 3y, gets me 3y minus 2z is equal to negative 74. Combining like terms, 3y minus 3y just happens to cancel. I'm left with negative 2z is equal to negative 74. Now, once I've gotten to this point, I'm down to a system of 2 equations with 2 variables. My job is to solve this equation the easiest way possible. Well, the easiest way possible is to realize that y disappeared. Divide both sides by negative 2, I get z is equal to 37. Once I know z is equal to 37, I know 4y plus z, which is 37, has to equal 113. Subtract 37, I get 4y is equal to 76. And if 4y equals 76 divided by 4, you get y is equal to 19. I know both y and z, and I know x is equal to 3y. So I know x is going to equal 3 times 19, so x is going to equal 57. 57, 19, 37 is the answer to the system. Use the simple substitutor to get it down to a system of 2. Simplify as much as possible and solve this either elimination substitution, or if you get lucky and this type of thing occurs, you've already got an answer. Use that answer to find the other answer, and once you found both those answers, go back to the original and find the third answer. Number 4, same type of problem. This time the bottom equation has only 2 variables in it. Very easily can be x equals 4z. So if x equals 4z, I can go right there, and I can go right there and change x's to 4z. So if I go to the top equation first, 2 times 4z makes 8z, plus 2y is equal, or minus z is equal to 55. Simplifying, I'm going to keep y on the left, z on the right, just for alphabetical order. So 2y, 8z minus z makes plus 7z is equal to 55. The second one, if I put 4z right here, 3 times 4z is 12z, minus y plus 2z is equal to 60. So that's the second equation. X changed to 4z times 3 made the 12z. Everything else stayed the same. Combine like terms, keeping y left, z right. So negative y plus 14z is equal to 60. So now my system of equations, this has just y and z in it, so I can eliminate, substitute as normal. This time elimination looks much more friendly. I'm going to double this equation. Negative 2y, positive 2y will cancel, so negative 2y plus 28z is equal to 120. 2y minus 2y cancels. 7z plus 28z is 35z. 55 plus 120 is 175. Divide by 35 on both sides. That's going to be z is equal to 5. Once I know that z is equal to 5, I can go back to any equation. I'm going to go right here. I know that 2y plus 7 times z, which is 5, so 7 times 5, 35, is equal to 55. Move the 35 over, that means 2y is equal to 20. Divide by 2, y is equal to 10. And finally, I know x is equal to 4 times z. Z is 5. 4 times 5 is equal to 20. So x is 20, y is 10, z is 5. X first, y second, z last. So 20, 10, 5 would be the correct solution to that problem. Write your answers in order triple. X first, y second, z third. Number 5, addition of vectors. This is the same exact addition of vectors type problem we've been seeing for, it seems like, forever. So job 1 is to change both of these into our rectangular form. Slide that over so we can see. So if I do negative 6 cosine of negative 35, I'm making sure I'm in degrees, not radians. And I do negative 6 sine of negative 35, that gets me my rectangular components for the first vector. So this vector comes out to negative 4.91 I vector plus 3.44 j vector. This other vector is 10 at an angle of 125, so if we do 10 cosine 125 and 10 sine 125, that gets me the I and the j components for that. So it's negative 5.74 I vector plus 8.19 j vector. So to get the resultant vector, I simply have to add these together algebraically. Same sign add, same sign add. So negative 10.65 I and positive 11.63 j is the end result of those two vectors. Now, once I've gotten the rectangular form, and have that on your paper. If you have that correct and you mess up from this point forward, you're going to get half credit for getting the correct resultant in rectangular form. To get full credit, you have to go back to polar form, which again is this form correctly. So step 1 of polar form is r is going to equal the square root of the squares of these two numbers. Squares are always positive, so ignore any minus signs in this step. So just like that, if I type in 10.65 squared plus 11.63 squared, that's what's underneath the square root. So if I square root that number, 248.6794, r is going to equal whatever that is, 15.77. Step 2 is find a reference angle alpha, which is always inverse tangent of the absolute value of the second over the first number. Absolute value bars make everything positive, so ignore any minus signs in this step. So inverse tangent of 11.63 divided by 10.65. You have to do inverse tangent also. If you just do the quotient of those two numbers, that's not the right answer. Inverse tangent of that quotient it comes out to 47.52 degrees. And step 3, now's where the minus sign matters. We need to determine a quadrant we're in. If I'm moving left horizontally and up vertically, left and up, imagining a system of like a coordinate system here, I go left and up, that puts me into the second quadrant. So in the second quadrant, the rule for theta is 180 minus alpha. So 180 minus 47.52 comes out to 132.48. And polar form is simply the r value with the theta value. So 15.77 at an angle of 132.48 degrees would be the end result for full credit. Again, have that written on your paper. If you get this all wrong, you still get half credit for having the right resultant in rectangular form. And that's not even that hard. Your calculator gets you these numbers, add or subtract based on sign by like terms. Getting that's real simple. Getting back here is a little more complicated, but really it's not that terribly difficult if you practiced it. Number 6. Addition of fractions. We can't add fractions until we get a common denominator. We don't want to get a common denominator until we factor a quadratic trinomial denominator to compare what we're looking at. So 3x plus 4 is going to stay as is. I can see clearly that x plus 5 times x minus 1 is the factor form of that quadratic. 5 times negative 1, 5 plus negative 1, so that's a real simple quadratic trinomial. Comparing what I have for a factor here with what I have for a factor here, they're the same except for sign. So what I want to do with this second fraction is I want to take this and change the signs. Let x become positive, let 1 become negative. And since I changed the sign there, I'm required to change the sign elsewhere, either in front or on top. Since the front's a minus, I'm going to change it right there. If the front were a plus, I'd change on top. And then I leave the top as is. So, bottom sign's changed, front sign changed, top sign stayed the same. Once I get this looking exactly the same as this, legally, change sign, then I got to get this thing on that also. So I need to put an x plus 5 here. That requires me to put an x plus 5 on top. This plus sign is attached to this 3x, so when I distribute, I'm distributing a positive 3x through. So, the top of the blue fraction is going to remain 3x plus 4, because nothing happened to its denominator, nothing happens to its numerator. The top of this other fraction, I'll do it in green, is going to be plus 3x times x, that's plus 3x squared, plus 3x times 5, that's plus 15x. And the common denominator of these two fractions is simply x plus 5 times x minus 1. Final step then is to add like terms on top, if at all possible. And obviously 3x and 15x are like terms. I like descending order. I don't require it on this problem, but I'm going to put 3x squared first. 3x and 15x both positive make 18x. And then plus 4 all over x plus 5 times x minus 1. Number 7, simplify. What's wrong with this? Obviously, hopefully, obviously for you guys, is there's a radical in the denominator. We don't like that. And the fix for radical in the denominator is multiplication by the conjugate of that radical. So this is the binomial radical. Its conjugate is 2 plus the square root of 3. I need to treat both the top and the bottom as a single object, so I'm going to put parentheses around both objects. And what I need to do here is I need to do some foiling on top and just a shortcut FOIL on the bottom, because again, this multiplication by a conjugate is just one of those special cases. So, first times first on top makes 6 times the square root of 3. Outside times inside, 3 times 3 makes plus 9. 3, and then square root of 3 times the square root of 3 makes 3. Inside times inside, negative 2 times 2 makes minus 4. Last times last, negative 2 times the square root of 3 makes minus 2 times the square root of 3. And on the bottom, again, we can shortcut this because the outside product, 3 square root of 2, inside product negative, 2 square root of 3, inside product negative 2 square root of 3, cancel. And that's on purpose. That's what should happen. So all we have to do to multiply the bottom is first times first and last times last. And when you multiply the square root of 3 times itself, you get 3. Opposite signs are giving me a negative. 2 times 2 makes 4. Final step, add like terms. So on top, 9 minus 4 makes positive 5. 6 square root of 3 minus 2 square root of 3 makes plus 4 square root of 3. And 4 minus 3 on the bottom makes over 1. If you put the over 1, that's fine. If you just put 5 plus 4 square root of 3, that's fine. So I'm fine with that answer if you just left it as 5 plus 4 times the square root of 3. Realizing that it is over 1, and that means the same thing as just that. Either one of those is fine. Number 8, find x. Okay, anytime you're supposed to find x in an abstract equation, or for that matter, any variable in an abstract equation, you don't want parentheses in the equation. So start there, m times this and m times this. M is a whole number structure, so simply multiplying by the tops there. So a over v plus r does not change. M times 1 over x is m over x. M times 1 over y is m over y. Get rid of parentheses first always. Second step, get rid of parentheses, or sorry, fractions always. So the least common denominator of these fractions is x times y times v plus r. Multiplying each fraction by that, reducing what's possible, then multiply the rest. So v plus r cancels v plus r, I get axy. M over x times xy, x cancels x, so I'm left with my times v plus r. Y cancels y here, so I'm left with mx times v plus r. And then finally, once you get rid of the fractions, if there's parentheses showing back up again because we have a binomial common denominator, then just go ahead and distribute one more time, just to finish this off. So simplify this and this with the distributive property. That leaves me with axy equals mvy plus mry plus mvx plus mrx. So you get yourself down to a point where you got a bunch of terms, no fractions, everything has whatever letters it has in it. And at this point, this is when this really matters now. It says find x. So at this point, anything containing x is more important than everything else. So this has an x in it, this doesn't, this doesn't, this does, and this does. So I need all the x's to get together on the same side of the equation. I'm going to choose the left side. So I'm going to take this guy and this guy over to the left. I'm going to keep these two guys over on the right. And I'm going to keep axy right where it's at. So axy staying where it's at, moving mvx and mrx to the left. And I'm keeping mvy and mry right where they're at, so they stay positive. So this stayed right where it was, it stays positive. Moved, both became negative. Stayed, both stayed positive. The left-hand side now contains a common factor of x, so we're going to take that common factor of x out. If I take x out of this term, I'm left with ay. Take x out of this term, minus mv. Take x out of this term, minus mr. When you're doing that step, nothing happens to the right-hand side. Final step, I want x equals, so I have to divide by the stuff being multiplied by x. So this stuff goes on the bottom, and this stuff goes on top every time. whatever the thing you're looking for is being multiplied by, what is being multiplied goes in the bottom. So x is going to end up being this fraction, and the top of the fraction is whatever's on the side by itself. And what goes in the bottom of the fraction is what's being multiplied by x. So ay minus mv minus mr. X equals a bunch of stuff that isn't x. That's what you're looking for on those problems each time. And just to give you the whole thing at once, there you go. Get rid of parentheses, get rid of fractions, get rid of parentheses again. And once you get everything down to as simple as possible, everything containing the letter you care about on one side, everything else on the other, factor it out, divide by whatever is being multiplied by it. That's how those problems work every time. Number 9, quadratic equation. Quadratic formula is my choice, so this is minus 1x, so a is equal to positive 8, b is equal to negative 1, c is equal to negative 1. Which means, if I go ahead and create the structure of my answer, x equals that. What goes in the front box here is minus b. b is negative 1, so minus b is equal to positive 1. What goes down here is 2 times a. A is equal to 8. 2 times a is going to be double that, so 16. What goes inside the radical is simply b squared minus 4ac. b squared is positive 1. b squared is always positive. Minus 4 times a times c. A and c are whatever they are. So b squared is positive 1. 1 times 1 is 1. Negative times negative makes it positive. Minus 4 is minus 4. A is positive 8. C is negative 1. These get multiplied together, and a lot of times this happens where you get opposite signs there, or I should say the same sign. So negative negative makes positive. 4 times 8 times 1 is 32. 1 plus 32 is 33. And that's it. So x equals that. Square root of 33 doesn't simplify. You can't reduce the fraction. That's it. So I can't guarantee it'll be that 100% easy on the test, but if this happens to reduce, such as let's say the square root of 12, 2 times the square root of 3, that kind of thing, do that. But again, it will be about that level, I would say. Number 10, simplify. I can't simplify this addition of fractions until I make this second fraction into a simple fraction. I can't have a fraction inside a fraction. This is the only fraction doing that, so times a times a times a, all within this fraction. This is all by itself. This a plus doesn't matter. So a times the 3 pieces of fraction that contain the fraction inside of it. So I'm going to keep this a plus out in front, so that's that. And then here I'm going to make all those better. So if I multiply everything by a, on top I get x times a is ax. Bottom left I get a times x is ax plus, and here the a's cancel, so plus x. So that's job 1. Job 2, get a common denominator. So now that I've got it down to a simple fraction being added to this a, I need both top and bottom of this being multiplied by ax plus x. And that gets me a times ax is a squared x. A times x is plus ax. That's going to be plus ax all over ax plus x. So if I add the two fractions together, combining like terms in the process, a squared x has no like terms. 1ax plus 1ax makes 2ax. On the bottom I've got ax plus x. That's the right answer. I wouldn't count that wrong. One extra thing I noticed as I was doing it, I didn't notice until just a moment ago, but every term contains the letter x. Division by x is legal and I'd say advisable. So if I divide everything by x, a squared plus 2a over a plus 1. That is a 1x, so make sure that plus 1 shows up if you do reduce. Again, I'm not going to require reduction, so if you want to leave it unreduced, if you're more comfortable with that, that's fine. But you should hopefully be looking for reduction of fractions when possible. Number 11, solving a system of equations. Just 2 equations, 2 variables. The difficulty here is all the fractions and decimals. So I would take this top equation times 3 to get rid of the fractions. 1/3, 2/3, and a constant, so 3 is the common denominator. 3 times 1/3 x is going to be 1x. 3 times 2/3 y is going to be plus 2y. And 3 times 22 is 66. In each case, divide first. 3 divided by 3 is 1 times 1x. 3 divided by 3 is 1 times 2y. 3 times 22, 66. 2 decimal places, 1 decimal place, 2. So this needs an extra decimal place. Everything has 2 now. So 2x plus 70y is equal to 1,716. So just like that, I've got a system of equations, 2 equations, 2 variables. Very simple system. I could double this, multiply by -2 to make the x's cancel. The other thing is 2, 70, 117, 16, both divide by, all three divide by 2. If you notice that, that's allowed. I'm going to go ahead and do what I think most of you probably would have done, which is times -2. So -2x minus 4y is equal to -132. 2x minus 2x cancels. 70 minus 4 is 66y. And 1716 minus 132, 1584. Divide both sides by 66. I hope that's a nice number. Let's try it out. So 1584 divided by 66 comes out to 24. Once we know what y is, I go back to one of the equations. I like the blue equation because the numbers are smaller. X plus 2y is equal to 66. X plus 48 is equal to 66 minus 48. 66 minus 48 is 18. And again, with the system of equations, we're looking for ordered pair answers. X first, y second in an ordered pair. Number 12, simplify 5 times the cube root of 25 times the 4th root of 5. So first off, some students read this improperly. So that 3 is attached to the root. That's just 5 to the first power outside. And that 5 is the very last thing you deal with. So as I go, this 5 out here is just going to be just hanging out. We're not doing anything with it yet. I've got a cube root that's important, but not yet. Then I got a whole bunch of stuff inside the cube root that is important right off the bat. So I want both of these numbers written as the smallest number raised to a power possible, and that number would be 5. So 25 is 5 to the second power. That's being multiplied by 5 to the 1/4 power. Power divided by root to make the power. Again, the cube root's important, but not yet. Inside the cube root, just looking at these numbers, pretend there's not a root there. 25 is 5 squared. That's the 4th root of 5. That's 5 to the 4th. You get what you get there. Next step. We need to multiply these two 5s by adding these two powers. If I do 2 plus 1/4, that's 8/4 plus 1/4, which is 9/4. So that's what's going to happen. You're going to get both of these as the same number raised to a power. You write that number down and then add the powers up. Whatever they are, they are. So 2 and 1/4 add up to 9/4. Once you get to this point, now this root matters. This multiplies by that to make a new expression. So 5 is still out here. It's being multiplied by this radical, but it's going to be rewritten now as a fractional power expression, 9/12. 5 stays 5, 9 stays 9, 3 times 4 makes 12. 9/12 reduces to 3/4. That's not going to happen every time, but it's going to happen enough that you should look for it, so be watching for that. Once I get to this point, 5 to the 3/4 times 5. So this whole time this 5 outside has been hanging out, waiting for you to do something with it. Now you're ready to do it. This 5 being multiplied by this 5 is just the same way we did these multiplication of 5s. I'm going to multiply these 5s by adding up these two powers. 1 plus 3/4 is 4/4 plus 3/4, which is 7/4. So 5 to the 7/4 power is the final solution to that problem. Expect on the test to have a number out here that's going to match the numbers in there, but again, the last step is where you deal with that number outside, not till then. Be patient. 13. The problem on the test is going to have the same thing occurring as what's happening in this problem here, and that is that the square root of 12 can be simplified. Before you worry about getting the square root of 12 off the bottom, simplify it. You want everything, all radicals, to be as simple as possible before you worry about the whole get the radical off the bottom thing. So, square root of 5 is up there, square root of 12 is down here. Square root of 12 is up there, square root of 5 is down here. Then I got 2 times the square root of 60. At this here I can just go ahead and make 2 times 2 times 3 times 5. So I can go ahead and do that whenever I feel like it. What I want to be patient with here is these square roots that can simplify. So I think everybody already knows the square root of 12, but I'm just going to do it in pieces here. Square root of 12 is 2 times 2 times 3. And this also is going to be the square root of 2 times 2 times 3. Pair of 2's inside gets to pull 1, 2 outside. Pair of 2's inside, pull 1, 2 outside. So what we end up with as an expression is 3 times the square root of 5 over 2 times the square root of 3. Leaves some space. Plus 8 times the square root of 3 over the square root of 5. Leaves some space. And then here I'm going to pull a pair of 2's out as a 2. I'm going to get minus 4 times the square root of 15. Okay. I don't have to be patient with that last term. The last term is going to be like it always is. I have to be patient with these terms because, again, square root of 12 is the same as 2 times the square root of 3. The square root of 3 is better than the square root of 12. It's easier to work with, so you want to have it at that level. If you leave it as a 12, you're going to have too big of a number. You're going to have to do the same kind of stuff that you did with this, with all this over here. Most people don't think about doing that, and all of a sudden they got weird stuff in their papers. So deal with that first. Times the square root of 3 over the square root of 3 times the square root of 5 over the square root of 5. Now this says 2 times the square root of 3, but the radical is what the problem is. So square root of 3 times itself makes 3. All of a sudden there's no radical in the bottom. So that's fine to do it that way. So 3 times the square root of 15 over 3 times 2. 8 times the square root of 15 over 5. Minus 4 times the square root of 15 over 1. If you notice this, it's worth doing. If you don't notice it, you're still going to get the right answer. It's just not going to be reduced. I personally look for that kind of stuff. So the 3 and the 6 reduces to 1/2. That's better than 3 times the square root of 15 over 6. And finally, common denominator of 10. Times 5 times 5. Times 2 times 2. Times 10 times 10. 5 minus 16 is, or sorry, 5 plus 16 is 21. Minus 40 is negative 19. Negative 19 square root of 15 over 10 is the best final solution. If you have negative 57 square root of 15 over 30, which would have happened had we not reduced here, that's still correct. I'm not going to count it wrong. It just, reducing would be better, but I'm not going to count it wrong to get the right answer. Number 14, find the equation line that passes through the points. This is just a basic find the equation line problem. So job 1 is to find the slope. Slope is y2 minus y1 over x2 minus x1. y2 minus y1, x2 minus x1. Alright, so just one minus the other like that. Minus minus means plus. Minus 2 plus 5 is 3. Minus minus means plus. 7 plus 2 is 9. 3 ninths reduces to a third. I always reduce slope as much as possible. It makes life easier. So I'm looking for an equation line that passes through either one of those 2 points. Take your pick. I'm going to go 7, negative 2. That has a slope now of 1/3. Alright? I could have just as easily gone with negative 2, negative 5. Doesn't matter which point I pick. One of those 2 points and my slope I just found. Y is equal to mx plus b. 7 times a third is 7/3. Since this is thirds, I need to make this negative 6/3, creating that common denominator. Move the 7/3 over. I'm going to add, because the signs are the same, I'm going to end up getting b equaling to negative 13/3. M is 1/3, b is negative 13/3, y equals mx plus b. Fractions for both, I wouldn't put that past it on the test. It'll be what it is. You know how to add and subtract fractions, multiply fractions, you may be able to work with them. So slope is a fraction, y-intercept a fraction, I wouldn't be surprised. If it came out slope whole number, y-intercept whole number, vice versa, whatever. But I'm going to give you 2 points, find me the equation line, pass into points. It's the same process we've been doing since Algebra 1. Number 15, the one thing that's going to trip people up if you're not being careful is this minus sign in front of the second fraction. Be very, very careful of that. The common denominator of the fractions, because we don't like fractions, is 15. I'm going to multiply the entire thing times 15. When I do 15 times this, 15 divided by 5 makes 3. That's being multiplied by the top of 2x minus 7. 15 divided by 3 is 5, which is actually minus 5 times 4x minus 2 to the top. And 15 times negative 11 is negative 165. No fraction there, no reduction possible, but just multiply the numbers you have. And again, just highlighting the thing that I'm really focusing on here is that minus sign. That minus sign is right there in front of the second expression. Again, 15 divided by 3 made the 5, but it's attached to that minus sign being multiplied by the top. So now, when I distribute, 3 times 2x makes 6x. 3 times negative 7 is negative 21. Negative 5 times 4x is negative 20x. Negative 5 times negative 2 is positive 10. That's the sign that a lot of you miss on those problems. So be very careful that you're focusing on that, that minus sign which is there, which is distributing through to create that plus sign. It still equals negative 165. At this point, I've just got x as a number, so I'm going to move the 21 and the 10 over to the other side. Minus 21, so it's going to be plus 21, plus 10, so it'll be minus 10. 6x minus 20x is negative 14x. Negative 165 plus 21 is negative 144. Minus 10 is negative 154. Add or subtract however you want to. And if you're not comfortable doing that in your head, negative 165 plus 21 minus 10 equals. Your calculator can work it out for you. I hope that you don't rely on your calculator that much, but if you're taking a test, you want to ensure that you're getting calculations correct, by all means, use it as a tool. Divide by negative 14 on both sides. And 2 negatives make a positive. 14 goes to 154 11 times. So x equals 11 is the correct answer to that problem. I saw 3 or 4 problems on the whole test that had little tricky things like that going on. So be careful, be watchful, take your time through the process. Know which problems are going to be tricky and prepare for them accordingly as you attempt the problems on Tuesday.